So learning target 3.5 asks us to convert between and express a number in standard form and scientific notation. So for the first two examples, let's focus on taking a number in scientific notation and converting it to standard notation. So in this example A, the number written in scientific notation is 3.67 times 10 to the 8th. So because this exponent is a positive number, it means this is a really large number. It's a big number. What this 8 actually means is we want to take this decimal point and we want to move it 8 times to the right in order to express our number in standard notation. So if I have 3.67, I'm going to take my decimal place and move it 1, 2, 3, 4, 5, 6, 7, 8 times to the right and put it right there and fill in the zeros. Now I'm going to write this as my answer, 367, followed by 6 zeros. Which means that 3.67 times 10 to the 8th is the same thing, and we would write it in standard notation as 367 million. Now let's do example B. So, you see that the number written in scientific notation here is 9.08 times 10 to the negative 5th. So, the negative 5 exponent in this example means that this is a really small number. What it means that is, if we actually want to write this number over here in standard notation, we need to take the decimal right here and move it 5 spaces to the left. So our number is 9.08, and we want to make our decimal go 5 spaces, 1, 2, 3, 4, 5, to the left, and we will fill in with the remaining zeros. So to write this in our final answer in standard notation, we have 0.000908 in standard notation. Now if we zoom back out, we can also go in the opposite direction. And we want to write the following numbers in scientific notation. So, C is written in standard notation. And our number is 850,600,000. So, we want to express this in scientific notation. In scientific notation, you always have your base number multiplied by 10 with your exponent. Now the base number, which I will call x, has to be less than 10 or greater than or equal to 1. So, if we take this number in C, which is 850,600,000, our decimal place needs to go right there, so that our base number is going to be 8.5. Now, we need to count how many decimal places we need to go to the right in order for us to express this in scientific notation. So if our decimal place was right here, we would need to go 1, 2, 3, 4, 5, 6, 7, 8. So that means we will write 8.5 times 10 to the 8th. Again, because that number 8 means that we would take the decimal and move it 1, 2, 3, 4, 5, 6, 7, 8 spaces to the right to express this number in standard notation if we were going in the other direction. Now in example D, we can see that this is a very small number. So we know that our exponent is actually going to be negative. And once again, our base has to be greater than or equal to 1 or less than 10. So if I put the decimal place right here, that means my number would be 18. And that violates this rule. So that means we know that we can't put the decimal after the 8, but we have to put it just before 8, which will make our base 1.8. And let's count how many places this is away from the decimal. It's 1, 2, 3, 4, 5. So we will write 1.8 times 10 to the negative 5th, because if we were to go in that direction, the opposite, this means that we want to take our decimal and move it 5 spaces to the left, which would give us this answer in standard notation. So take a second to try this individual example, which asks us, what is the following number expressed in scientific notation? And when you're done, resume the video to check your work. And the answer here is 6.58 times 10 to the negative 6. Since it is a very small number, as indicated by the decimal point being on the left, we know that our exponent is going to be negative, so you probably could have eliminated option A. And additionally, since you know that our base number has to be less than 10, you also could have eliminated C and D. So not only could you answer this question using process of elimination, but if you check your work, 6.58 times 10 to the negative 6, you'll see that in option B.